All right, welcome to the electronics class for September the 14th. First thing we're going to do is go over the quiz that you guys took last time, talk about how we got the answers to that. There's still a few of you who have not yet taken the quiz, um, and a few of you have not turned in a couple of assignments. I hope you guys realize that the only way to learn electronics is to do the homework. You can't just sit there and watch the lecture and say, "Oh yeah, I got it. This makes sense." You got it. You got to do the homework. Okay. All right. So let's look at the um, okay. Hang on a sec. I gotta open up the right thing first. Okay. Just a second here. I've got too many screens open here. All right, now we can do it. All right, so you should now be seeing my Zoom screen. Let's click on electronics. A little bit slow here today. All right. The homework that you guys should be doing, or the homework that was due today was simple voltage dividers. You can see that what we're going to do today, after we talk about the homework, is we're going to talk about how to use a voltage divider to drive an LED, and also we're going to talk about how to use breadboards. Some of you know that, but most of you don't. But before we do that, let's talk about the homework. All right, question number 1. You were supposed to build a voltage divider that had an input voltage of 12, and I wanted the output voltage to be 3.5. And hopefully you didn't need me to tell you this, but just because I'm such an incredibly nice guy, I told you anyway. Okay, so this is what the circuit for a voltage divider looks like. Notice that we just have one branch. Now, some of you might think that this other branch here, this one right here, some of you might think that that's part of the circuit. And so you need to know something very important. When you've got a voltmeter, okay, it has an internal resistor that is essentially infinitely big. So current cannot flow through a voltmeter. So this voltmeter might look like he's part of the circuit, but you can treat it as if he's not even there. So all of the current is going to go through those two resistors and come back into the battery. No current is going to go like that. All right. So if you got two resistors, and then what you do is you pick off some place in between the two resistors, and then the other place that you pick off is connected directly to ground. What you've just created is a voltage divider, and they are surprisingly useful. You're going to see voltage dividers all over the place. All right, so you could have picked any combination of resistors to do it. There's an infinite combination that will, but there's also an infinite combination that won't. So as long as you got an output voltage of 3.5, then I call that good. All right. Okay. So next, what you had to do was to modify your voltage divider. So your input voltage now is not 35 anymore. Your input voltage now is 37, or I'm sorry, the input voltage is not 12 anymore, it's now 37. And I want an output voltage of 14. And again, as before, you could have used any combination of resistors as you want. So if the numbers that you came up with were different from what somebody else came up with, that's fine. Okay, so Simon is saying that he wasn't able to get exactly 14. He got 14.02. Yeah, that's okay. I realize that because the software does not actually allow you to use infinitely fine increments, there is a finite step size. So you can't get it exactly right. So if you got it to 14.02, that's fine. If you got it at 13.99, that's fine. Okay. So as long as you are within round off error of 14, then that was good. All right. Question number 3. All right. So I'm telling you that the input voltage is 12. I'm telling you I want the output voltage of 3.5. And this time, I'm telling you what the value of one of the resistors has to be. So once I tell you that, then there's no longer an infinite combination anymore. There's one value and only one value of R1 that's going to do the job for us. Okay. And I purposely picked a value of 930 ohms for the resistor because I didn't want you to be able to go onto the online circuit simulator and just do what I call trial and error until you finally got it. I didn't want you to be able to do that. I wanted you to calculate this by hand. What I'm hoping right now is that one of you will be willing to share with the rest of us how you did that. Would anybody be willing to unmute themselves and tell us how you do this? Come on, somebody be brave here. Tell you what, I'll draw the circuit for you, if that'll make it easier. All right, so here's our battery. Here's the one resistor, here's the other resistor. Okay, and these are the two leads. And oh, I forgot already what I said I wanted that to be. So let's see. So I wanted to be 3.5. So let me write this down. So 3.5, 12 volts, and 930. Okay, so let me go back to this. All right, so this was 12 volts. Oops. Okay, so we had 12 volts here. This was 930 ohms. And I wanted this voltage here, delta V, to be 3.5. So your job was to figure out what value did that resistor have to be. Okay, don't worry, Isaiah, if you're having trouble, that's with your internet, that's fine. Come on, somebody's got to be brave enough to tell us how are you going to calculate this?
You gotta use the equation it gave you from the reading. Basically, it says V out, which is like the output, which is 3.5, is equal to V in, which is 12, times R2, which is, we don't know that yet, so just write it as R2, all over R1, which is 930, plus R2, which we don't know yet.
Okay, so you obviously read the book, or read the online textbook, so congratulations, thank you for doing that. So this will in fact work. Now, hopefully you guys remember this is not the way that I taught you. I have a different way of doing it, and I think that my way is easier for most students. But if you are good at math, if you are really comfortable with your mathematics skills, you can take this equation that the book gave you, because we know what V out is, we know what V in is, we don't know what R2 is, but we do know what R1 is, okay? So from this point on, it's no longer an electronics problem, it's just a math problem, but it is kind of a messy math problem. Now, if you are in Math 2 honors, and some of you are in Math 3 or even higher, so you look at this and you say, okay, this is no problem, this is easy, I know how to do this. And so you're going to multiply both sides by R1 plus R2. Okay, and that cancels that. And then you're going to distribute that out. And then I'm purposely doing this fast because I do not want to spend time doing this method, because I have another method that I like better. But let me just say that, so if we do that and multiply that, distribute that out, and then solve for R2, we can use our math skills to solve for it, okay? That will work. But I taught a different way, and my experience as a teacher over the years has been that my way is easier, especially for people who aren't really comfortable with mathematics. So although there is absolutely nothing wrong with the way that you just proposed, I would like to do it a different way, just because I think that this different way is easier. Okay, so let's say, so this is 930 ohms here. This we don't know, but we do know that the delta V that we want between these 2 points is 3.5. So can somebody explain my way of doing it? Okay, this has me concerned. All right. Okay, so I will explain it, and hopefully this will refresh your memories. Okay, so we know the total voltage is 12, right? And the voltage across this resistor is 3.5. So what does that leave us for the voltage drop across this resistor? Somebody type into the chat box or say it out loud. Okay, if the total voltage is 12, and so we use up 3.5 volts getting across this resistor, how much are we left with for the voltage drop across the other resistor? All right, so I'm seeing 8.5. Okay, I agree. Okay, so let me erase the question. Oops, I want to erase, not right. Okay, so we know that the voltage drop across this guy has to be 8.5. Okay, knowing that, can we calculate what the current is that's flowing through the circuit? Okay, because we have current flowing through here. And the beautiful thing about a simple series circuit is there's one loop and only one loop. So if we can just figure out what is the current that's flowing through this resistor, it will be the same current flowing through the other resistor. All right, so now, for sure, one of you has to be able to tell me, what is the current that's flowing through this resistor? If the voltage drop across the resistor is 8.5, the value of the resistor is 930, what is I? How about Jasper? Would you be willing to tell us how are we going to calculate what I is? What is the current that's flowing through that resistor?
What's the equation again?
If only I could remember it. My goodness, it had a name. What was the name of the equation that we use?
Ohm's law.
Ohm's law. Okay, very good. All right. So if we increase the voltage, that's going to make the current flow more, right? So that means we got a voltage up on top. If we increase the resistance, that's going to decrease the amount of current. So that means that must be on the bottom. Okay, so guys, this is an equation you must memorize. Every one of you must memorize this equation. And if you remember this, then you can rearrange it to get the other forms. All right, so now we know that the voltage is 8.5. The resistance is 930 ohms. And notice that those are all regular volts, regular ohms. We don't have any millivolts or kilo ohms or whatever. All right. So, Jasper, have you guys all got your calculators? I mean, everybody should bring a calculator with you to class. Don't show up without a calculator. So when you take 8.5 divided by 930, what do you get?
I got 0.0091.
0.0091 and a bunch of other digits too.
Yeah.
But that's probably good enough. Tell you what, let's carry one extra digit. So I see 39, but let's just round that to 00914. Okay, so this is I. Now, here's the important thing. If this is a series circuit, whatever current is flowing through I1, that same current is flowing through I2. Now, the pressure is going to be different because remember what voltage is. Voltage is basically like pressure. So up here, the pressure is really high. When it gets down to here, it's a little bit lower, but still not zero. And when it gets down to here, the pressure is now zero. So the pressure, which is another way of saying voltage, it changes. But, oops, I didn't mean to get rid of all that. Okay. But, so the pressure might change, but the current is the same. All right, so if we then know that the current through the upper resistor is 0.00914, the current through the lower resistor must also be 0.00914. So all we have to do then is use Ohm's law again. Okay, so if we got I equals V over R, this time we know what I is, and we know what V is. The thing we don't know is R. So how do we solve for R? We multiply both sides. So let me get rid of these marks here so they don't confuse us. All right, so I'm going to multiply both sides by R. That cancels that. So now R is up on top, but it's connected to this I. We don't like that. So let's divide both sides by I. So that cancels that. So what we're left with is R equals V over I. And we know what V is for this resistor down here. V for this resistor down here is 3.5. And we know what the current is. It's the same current as before, 0.00914. So get out the calculator. What is 3.5 divided by 0.00914? When I do that, I get 383, actually 382.9 and change. But if I round that off, 383, okay, that is what the value of the resistor needs to be. Okay, and I see that some of you in the chat box have got it. That's reassuring. Okay, so our answer is 383. But when we look on Canvas, why is it not showing up here? Let me stop the sharing here. It seems to have gone away. Oh, I know why it's not showing up. Okay, hang on a sec. My thing changed here. Okay, so let's go back here. Okay, so we just type in so into the screen here, we just have to type in, what did I say, 383. Okay, there we go. Now, those of you that know about significant figures, you might say, wait a minute, Mr. Hendricks, this number here only has 2 significant figures in it. And in fact, so does this. And even this, that 0 that you see there is not a significant digit. That's really just a placeholder. So all of our input values only have 2 significant figures. So some of you are going to correctly say we should not type 383 in the box. What we should type in is 380. We should round it down, okay? And that is, in fact, the better answer. But I realize that some of you are still learning about sig figs. So if you type 383 into the box, I gave it to you. I gave you credit for it. But 380 is actually the better answer because of significant figures. Okay. All right, question number 4 now. Again, we need to use your skill at calculating voltage dividers. Okay, so I see Caden is saying that he didn't get that, or that he's saying that Canvas is not marking it correctly. Did I do something wrong? Okay, so I'm getting 383. If you put in 303 into Canvas and Canvas marked that wrong, then I'll have to look and find out why is Canvas marking it wrong. Well, I'm not sure that I made a mistake. Oh, you're saying wig point because of Canvas being wrong? Possibly. I'm not sure. I'm not sure if I want to count that as a wig point. If 383 is not the right answer, that'll count as a wig point. If Canvas got it wrong, I'm not going to count that as a wig point. That's just maybe a typo. All right, so I'll go back into Canvas and I'll double check. And if you guys typed in 383 or if you typed in 380, and if Canvas marked that wrong, then I'll fix that for you. Okay, now question number 4. I want everybody to do question number 4 right now. Even if you did it before, I want you to do it again right now. All right. No, if 2,300 is, oh, so the question that I see on the chat box is, will you still be marked correct if you put in 2,300? If 2,300 is not the right answer, I'm going to have to mark it wrong. So I'll fix that. Okay, so forget that one, guys. Now let's focus on this new one. So we've got okay, guys, forget about the other question. We'll deal with that later. Let's focus on question number 4 now, okay? All right, so the question is saying that we've got an input voltage of 37, and we got 2 resistors. Okay, so this is 37, and we want the output voltage to be 14. And R1, which is this guy up here, which is 52 kilo ohms, so it's 52,000 ohms. Okay, so we want to know what this is. Oh, hey guys, you know, something just occurred to me. It could be, if I can think of a mistake that I might have just made, and if I made that mistake, I will put on the wig. Yes, I did make the mistake. Oh my goodness, I do see a wig point. You guys see what I did wrong up here? Oh, this is embarrassing. R2 was 930. I calculated as R1. Oh, that is a wig point. Oh, how embarrassing. Okay, let me go get the wig. I definitely earned it.
We did it, boys.
Okay, yeah, I didn't read the problem right.
Let's go,
Okay, so we're gonna
baby.
have to go back and, oops, let me put on my earphones. I use earphones because otherwise the sound, you get feedback, really weird feedback. Okay, yes, that is embarrassing. I stand corrected. Okay, so you see what the problem is. I just read the problem wrong, and it was my own problem that I read. R2 is not the upper resistor. R2 is the lower resistor. Okay, so here's our circuit. So this one here is the one that's 930. That makes all the difference in the world. Oh, how embarrassing. Okay, so our output voltage there is 3.5 volts, and our input voltage is 12. Okay, so I'm just going to do this one pretty quickly here. All right, so what is the current that's going to flow through here? Okay, so if I look at, oh my goodness. Okay, let me start this all over again. Okay, so here's my battery. Here's this resistor. Here's that resistor. This one here is 930, and this voltage here is 3.5. Okay, so the current then is voltage times divided by resistance. So that's 3.5, because this is only the voltage across this resistor, not the total voltage, divided by the resistance there, which is 930. Okay, so the current then is 3.5 divided by 930. Okay, so the current is 0.0038. That may not look like an 8, but it's an 8. Okay, and we know that that current is the same current here as it is here. The current never changes. All right, so if the voltage here is 3.5, that means the voltage up here must be whatever 12 minus 3.5 is. Okay, which is 8.5. All right, so R equals V over I. So that's 8.5 divided by the same current that we had before. So 8.5 divided by whatever our current was before. Aha, okay, So Canvas wasn't wrong, it was me. So my calculator here tells me that the resistor for this upper here needs to be 2,258, which if you put that in as the answer, I would give you credit. But hopefully you guys recognize we want to round that up to 2,300. So Canvas was not wrong. I just read the problem wrong. So actually, this is a good lesson. And there's always a learning opportunity for everything. Make sure you read the darn problem. Make sure you know whether you're talking about R1 or R2. Otherwise, you're going to end up wearing the wig and embarrassing yourself. And everybody's going to take screenshots of it, and then it's going to end up in the yearbook. And terrible, terrible, terrible. Okay, now let's get back down to question number 4. Okay, so this time, notice this time R1 is the one that I'm giving you, not R2. Okay, so let's not make the mistake that I made last time about getting the wrong resistor. Okay, so R1 is the upper resistor. So this is R1, R2 is the lower resistor. Okay, so this time the voltage is 37, that's the total voltage. And we want our output voltage to be 14. So then the question is, what should R2 be? So I'm going to sit here quietly. I want you guys to calculate it. And even though you already did it last night, I want you to do it again. Okay. So calculate, what does R2 have to be in order to give us an output voltage of 14? Tell you what, in order to save time here, I'm worried that we won't have enough time to cover the important stuff we need to get to. Would somebody please unmute themselves and tell us how to solve this problem? How about Tristan? Would you be willing to do it? Worth calling Tristan. Come in, Tristan.
Hey, I'm just thinking about it for a second. Sorry.
Okay. Well, how about if I give you a hint? Okay. So we know the voltage drop across the lower resistor. Can we then calculate what the voltage drop across the upper resistor would be? If we know the total voltage is 37?
Yeah, it'd be 37 minus 14.
Okay, which is?
23.
Okay. So now, if we know the voltage drop is 23, and we know that the resistor is 51 ohms, or 52 ohms. Boy, I'm just really being careless today. This is terrible.
Isn't it 52,000?
Yeah. Boy, if I wasn't already wearing the wig, I would have to put the wig on. But seeing as how I'm already wearing it, what are you going to do to me? Okay, so thank you. That is 52,000 ohms. Okay, that's kilo ohms. So 52,000. That's a 0 there. It may not look like it. Okay, so what is the current going to be then?
It'll be divided by 52,000.
Okay, you got your calculator? Can you tell me what you get?
Hold on 1 second.
Okay, if you don't have it, I can get it to you. So it's 0.00044. I'm going to round that down to 2. Okay, that's the current. Okay, so what are we going to do with that? Now that we know that number, what are we going to do with it?
We're going to take the voltage and divide the voltage by that number.
Which voltage?
Oh, the 23 volts.
We already did that. That's how we got that number, was by using the 23. So what we just calculated.
Oh, wait. Hold on.
Yeah. Okay. So what we just calculated was the current that's flowing through R1. Okay. Now, because it's a series circuit, we know that the exact same current has to be flowing through R2. Okay, so if we want to know what R2 is, we have to take the voltage across R2, which is 14, and divide
Yeah,
that
so
by the
it'd
current.
be 14 divided by the 0.0442.
Okay, and do you have an answer for what that worked out to be?
No, not. Yeah.
Okay, so I'll take it. So 14 divided by our last answer there. So I get 31652. So I get R2 has to be 652 ohms, which is too many sig figs. So I only want 2 sig figs, so I'm going to round up. So I'm going to write my answer as 32,000 ohms. Or I could write it as 32 kilo ohms, which I've got windows. You guys don't see all the windows I have, but Zoom gives me windows across windows across windows. Okay. So you guys, you can see that it's really easy to mess up. If you don't read the problem carefully and you get your R1s and your R2s mixed up, then yeah, you can easily make a mistake there. But assuming that you're careful about that, I think it's a straightforward way to do it. Now, the formula that the book gave you, that formula works, but I do not like using formulas that we don't know where they came from. That's just a Hendrix thing, okay? So those of you that say that you read problem 3 wrong the same way that I did, well, you know, I'm going to let you retake the quiz. So don't worry about it. Okay, so I'm going to move on now. Let's do a new share here. Okay. In your homework tonight, we're going to be using a different software package. The online circuit simulator that we've been using up until now is a really nice, simple, easy to understand circuit simulator, but it doesn't have the sophistication that we need. It doesn't have all the different components that we need. Okay, so what I want you guys to do, not right this minute. For right now, I want you to just watch. But in a minute, what I'm going to have you do is I'm going to have you open up a new web page, and we're going to go to a web page called tinkercad.com. Okay, can you guys all see up in the corner here? Tinkercad.com, right? That is a wonderful, wonderful website. Now, I have already been to there many times. So when I click on it, it's going to take me right straight in to Tinkercad. Now, those of you that were in my engineering class last year, you guys already have Tinkercad accounts. So if you click on it, it will also take you right straight into Tinkercad as well. Okay, but the rest of you, when you go into tinkercad.com here, it's going to ask you to sign up. And boy, it's really running slow today. Jeez. Okay, so I'm not going to go through the process right this very second about how to sign up for a Tinkercad account. I think it's pretty straightforward, but I want to focus on once you get signed up, what do you do with it? I want you guys to see the power of Tinkercad first, and after you've seen the power of Tinkercad, then we will talk about how to sign up for it, right? So those of you that were in my engineering class last time, you noticed that we did the 3D designs. We learned how to use Tinkercad to draw mechanical devices. Well, this time we're going to use Tinkercad to create circuits. So if you look right over here, okay, there's the 3D designs. We don't want that. We want circuits this time, right? So we're going to click on circuits. And now on mine, I already have some pre-made circuits in here. And so I want you guys to see how this works. I'm gonna create a brand new circuit from scratch. All right, so I click on new circuit and it thinks about it for a few seconds. I think maybe the fact that I'm running Zoom at the same time as Tinkercad, that's kind of slowing things down a lot. All right, good. Okay, so now if you look over on the right side, you'll see there's a bunch of different circuit elements. And some of these are ones you've seen before, like resistor. You guys have seen that. Battery, you guys have seen that. Now notice we've got a 9-volt battery and we've got a 1.5-volt battery and we've got a 3-volt battery, but we don't have a way to get any other voltage in the basic circuits. But if you click on up here and you go down to all, then you're going to see a whole bunch of new stuff that wasn't there before. And you're going to see, if you scroll down far enough, and you got to go way down, there is a, let's see, well, you got to go way the heck down here. Here we go, a power supply, right? So if we bring this power supply in here, we can set different voltages and currents, and so we can get any voltage we want. But for right now, I'm not going to do that. For right now, let's just stick with the basic components, and let's just go with a 9-volt battery. Okay, so I'm going to bring the 9-volt battery in here, and don't worry, it just defaults it as battery number 1. If you wanted to give it another name, you could, but I don't care about the name. And if you click on it, and then you come up on the left here, you see how you can rotate the battery around if you want. Not really super important, but you know, maybe might be handy. Okay, so I'm going to put the battery there. Okay, and I want a resistor. Okay, so here's a resistor. All right, so I bring the resistor in here. Okay, and so then now if I want to just hook it up, so I can take, if I click there, I get a wire. And let me zoom in a little bit so it's a little easier to see. Okay, so just by clicking anywhere I want, okay, I can draw wires. Okay, bingo. All right, so electricity is now flowing, or at least it will be. On these, I have to start the simulation. So I start the simulation, electricity is flowing, but I don't see anything. Now on the old circuit simulator, it actually showed you the electricity flowing, but this time around, it doesn't show it to you. So I want to know if the electricity actually is flowing. So I'm going to click on this, and then I'm going to hit the delete key on my screen because I want to bring in a multimeter. All right, so down here at the bottom, I've got this thing. So this guy, he is what we call a multimeter. So you can see we have a choice here. And the reason we say multi is because he can measure multiple things. So he can measure voltage, or if I want, he can measure amperage, which is current, or I can make him so he measures resistance. Okay, so right now, let's set him for amperage. So I want to know how much current is going to flow through here. All right, so if I click here, and then it starts a wire, and I bring it over here, and if I click here, okay, I've now connected that up. But current actually isn't going to flow until I connect up my circuit. So bingo. Okay, I now have a circuit. Nothing's flowing right now because I haven't started my simulation. But if I click on Start Simulation, hey, look at that. Now I have current, right? So I have 9 milliamps of current. All right. Now, what if I want to change the resistor? So the default value for resistors is 1, but you'll notice it's K. So that's 1 kilo ohm, not 1 ohm. So let's make it be, I don't know, how about 478 ohms? Okay. Now, if I start my simulation, you'll notice I have a different amount of current here. And the nice thing is I can actually change this real time. Like while the simulation is running, I can change it and you'll see that it changes the amount of current that's flowing through here. So this is the simulator that we are going to be using for the rest of the year. That other simulator was nice. It was quick and easy, and it's good to get you started. But as you can see over on the right side here, this new simulator has way more stuff, and we're going to learn how to do all these things. And notice it's even got an Arduino in here. Is that cool or what? Now, some of you are going to say Arduino. What's an Arduino? Don't worry, you're going to find out. Those of you that know what an Arduino is, this is really cool. We can bring in an Arduino. Let me stop the simulation. You can only bring stuff in when the simulation has been stopped. Okay, so we can bring in an Arduino and we can program it the way that you guys learned in the engineering class. Okay, but for tonight's homework, we're not going to do the Arduino. We're just going to do basic stuff. All right, see how that works? Okay, now let's suppose I want to make a voltage divider. Well, what I do is I bring in another resistor, and if I click here and here, okay, so I've got a wire. Now I come back over here, and bingo, okay, I now have a voltage divider. I have two resistors, one battery, okay, but how do I know? Let's move it over here. How do I know what the voltage is? Well, this multimeter is going to help us out. Last time we used the multimeter to read amperage, but this time I want to use the multimeter to read voltage. All right, so what I'm going to have to do is I'm going to have to have one line that goes from here down to the negative side of the battery, okay, and then the other line I'm going to bring it around here because I could just cross over the top of the other line. I could do that, but I don't want to get people confused. Okay, so now when I start my simulation, you see that I'm reading voltage. So 6.62. Look what happens if I change the value of this resistor. Let's change it from 359 to 759. Do you see how the voltage changed just then? Or I would change the value of this resistor here from 1 kilo ohm. Let's make it be 2 kilo ohms. See, so the voltmeter here is going to read what the current is that's flowing through it reads the voltage across the two leads. Now, color is important. This lead right here is connected to the positive lead of the voltmeter. And if you guys have played with real voltmeters, you know that wire is always, always red. And this wire here is always, always black. So let's make them be that way, okay? And also another good thing to know is that any line that is directly connected to the plus side of the battery, it's good practice to make that always be red. And any line that's connected to the negative side of the battery is generally good practice to make that be black. And then this line right here that's somewhat in between, we can have that be some other color, okay? All right. So what I'm going to want you guys to do tonight for the homework is I want you to use our new and improved electronic simulator to make a voltage divider. And in the homework, I tell you how much input voltage I want, how much output voltage I want, and I also tell you how much current I want. So let's see how we would do that. So let's click on this wire and let's hit delete to make it go away. Let's bring in another multimeter. It's kind of nice. You can have multiple multimeters. This time, I don't want it to measure voltage. I want it to measure current. So I'm going to set it for amperage. And then I'm going to connect the wire up here like this to that. And then this one here up there like that. Okay. And so now when I start the simulation, you'll see the multimeter on the right tells me how much voltage I have. The multimeter on the left tells me how much current I have. So in problem number 1 of your homework tonight, I tell you that I want a certain amount of voltage and I want a certain amount of current. And so what you need to do is you need to figure out how to make that happen. So before we talk about the homework tonight, let's just make sure that you guys are okay with this new software simulator. Does this look pretty straightforward to you guys? So give me a yes if you think this looks pretty straightforward. Give me a no if you think this looks confusing. All right, good. All right, so most of you guys, in fact, all of you guys are saying that it's straightforward. Okay, good. All right, now before we talk about a few more things, there's a new component that we're going to be using in our homework tonight that you need to know about. So you guys probably know that there are regular old boring light bulbs, And then there's a special kind of a light that's called an LED. So this right here is an LED. So think of an LED as basically a light bulb, but you need to treat it very carefully. If you treat your LEDs right, they will last way longer than a regular light bulb will last, and they cost way less. LED lights are wonderful, wonderful things, but you have to treat them right. If you don't treat them right, you get yourself in big trouble. Let me show you what I mean when I say don't treat it right, right? So let's take a 9-volt battery, and let's take our LED, and so actually here, what I want to do is I want to turn it this way, and you're going to find out in a minute why I want to do that, but for right now. Okay, so I'm going to connect a line from the battery to the LED. Oh, rats, I forgot. I should have put it on the other side. LEDs are a little finicky. If you just hook them up any old way, like let's say you hook them up like this, okay? When you start the simulation, nothing's going to happen. The LED doesn't come on. LEDs only work if you hook them up the right way. Electricity can only flow one way through an LED. Anybody know what the D in LED stands for? Or how about the L, the E, and the D? Somebody tell me, what does the L, the E, or the D stand for?
Light emitting diode.
Light emitting diode, very good. And what is a diode? What does the word diode mean?
You're asking me or someone else?
Well, seeing as how you're online, I'll ask you.
Okay.
Oh.
Diode is this thing has two terminals and it allows flow in only one direction.
Very good. Okay.
It's an electrical component.
Yeah. So it allows current to flow only in one direction. So I just hooked it up here, and when I start my simulation, it didn't light up. That's because I hooked it up the wrong way. And by the way, I did that on purpose. Okay. The LED that we have in here, you see, let me zoom in on it. Okay. You see how there's a little lip on the right side and there's not a lip on the left side? The side that has the lip on it, that is the side that needs to be connected to the plus side of the battery. And so if you look on the battery, you'll see here that there's a red terminal and a black terminal. So the red terminal needs to be connected to the side with a little notch on it. The black terminal goes to here. So now when we start our simulation, the LED comes on. See how that works? Okay. Now, what you see there, that little star symbol, that's actually not a good thing. That's the way that the software simulator tells you that you just destroyed this LED. We just burned it out. And if we were meeting in person, I would purposely burn out an LED because it's an interesting thing to do. LEDs, I said, on the one hand, they're really robust. They can last a long time, but they're also really fragile. If you put too much voltage through an LED, you'll burn it out. And it turns out that 9 volts is too much voltage for this LED. So what we have to do is we have to build a voltage divider circuit so that it controls the LED and it gives it the right amount of voltage and current. So LEDs have to be used in a voltage divider circuit. So let's bring in a resistor. Okay. So what we're going to do is we're going to create a voltage divider. Okay. And then we're going to connect up to that, and then we're going to connect this down to here. Okay. All right. So what we've done is we have a voltage divider. So if I looked at the voltage across the LED right now, it's not going to be 9 volts, it's going to be something less. So if I just go with the default value there, which is 1 kilo ohm, let's just see what happens. Let's start our simulation. Hey, the LED is lit up. Okay, it's good. All right. But maybe it's not as bright as we'd like it to be. So let me stop the simulation here. And let me tell you one important thing about LEDs, and I want you guys to write this down. LED, and I've written it in Canvas too, but I want you guys to write it down in your notebooks here. LEDs are designed so that they work best if the voltage across the LED is 2 volts, plus or minus a little bit, and the current that flows through the LED, you want it to be 20 amps. Okay, so let's write this down here. Where'd my pen go? So this is really, really important. For an LED, you want the voltage across the LED to be about 2 volts. Doesn't have to be exact, but it needs to be in that range. And you want the current that's flowing through LED to be about 20 milliamps. If you design your voltage divider circuit like that, that LED will last for a long, long, long time. Okay, so let's see if we've got what we want here. So what I'm going to do is I'm bringing in a multimeter, and I'm going to set it right here. And let's see, I've got it set for voltage. I don't want that. I want it set for amperage. Okay, so let's start our simulation. So you'll see that we only have 7 milliamps flowing through our LED. Well, it worked. You can see that the LED lit up, but it's not as bright as it could be. All right, so I want the current through the LED to be 20 milliamps, right? So what we could do is we could just do trial and error. So should I increase the resistance here or should I decrease it? What do you guys think? Somebody type into the chat box. Tell me, should I increase or decrease the current, the resistance? Because I want the current to go up. So what should I do to this resistor here? Do I want more resistance or less resistance?
Let's try decrease.
Okay. Yeah, I want other people type into the chat box. Okay, so it looks like people are in agreement. People are in agreement to decrease. Okay, so instead of 1,000 ohms, let's go to 500 ohms, and let's see. Oh, hey, look at that. Okay, we're up closer to what we want to be. All right, but we're still not there. So let's try 700 ohms. Oops. Okay, that didn't work. All right, we went the wrong way. So let's try 400 ohms. Okay, we're getting closer. All right. Now I'm going to stop at this point because I don't want to give you the answer. Okay. It is possible that just by doing this method that I call trial and error, you can figure out what the best resistance needs to be by using trial and error. But I would be disappointed if you did it that way. I would hope that you guys would use your knowledge of voltage dividers in order to calculate what the current should be. That's the way that I would prefer that you guys do it. So use your knowledge of voltage dividers. And just remember that we want this voltage right here to be about 2 volts. And we want the current that's flowing through to be 20 milliamps. And so from that, I want you guys to calculate what should R be. Don't do it by trial and error. Use your mathematics skills and calculate it that way, okay? All right. Now, I had intended to talk about breadboards today, but we're running low on time. And I don't want to overwhelm you with too much stuff in too short of a time. So I am going to modify the homework assignment that if you look on Canvas, it tells you on Canvas that it's due next time we meet. I am going to modify that. I'm going to go on to Canvas and I'm going to have it due on Friday instead. Now, some of you are going to say, but wait a minute, Mr. Hendricks, we don't meet on Friday. Yeah, but Friday is still a school day, right? So what I'm going to do is next time we meet, I'm going to talk about breadboards. and how to make circuits using breadboards. And by the way, maybe you guys might not have noticed, if you look on the list of, or if you look over here on the right, you see this little baby right here? I have to stop the simulation. There, let me zoom out. That is a breadboard. Whoops. Okay, I accidentally started some wires there. Okay. So this baby is a breadboard. Some of you know what a breadboard is. Most of you probably don't. So I will talk about breadboards next time. Those of you that know what breadboards are, hey, you are absolutely welcome to go ahead and start working on the assignment tonight and take the circuit that you see right here and put it on a breadboard. Okay, take the resistor here, put it on a breadboard. Take the LED, put it on a breadboard. Okay, if you know how to do that, and I know that some of you do, hey, go for it, run with it, that's great. But if you don't know how to do it, don't worry. I'll talk about it next time. The most important thing that we need to do right now is we need to make sure that you guys know how to sign up for Tinkercad, right? So what I'm going to do right now is I'm going to log out of Tinkercad, assuming that it'll let me. Doesn't seem to want to let me here. Boy, it's really running slow. Okay, so I'm going to log out of Tinkercad. And so now what I'm going to do is what you guys are going to see when you go to Tinkercad. So when you type in tinkercad.com into your browser, it will take you to this page right here. All right. And in fact, you know what I recommend is everybody get on your computers right now and do it right now. Everybody go to tinkercad.com and you should see this. And once you get to this point, I want you to type into the chat box and say, got it, or I'm there, or something like that. I'm going to wait until I see everybody say they've got it. Okay, good. All right, that's close enough. All right, now, those of you that were in my engineering class last year, you already have Tinkercad accounts. So what you can do is you can go ahead and just sign in. But the rest of you probably don't have a Tinkercad account. So let's click on Join Now. And you'll see that it gives you an option here. If I wanted to set up a class account, I could do that, but I have purposely not done that because I think it works better if you guys have your own Tinkercad accounts. Rather than using a class account, I want you guys to have your own Tinkercad account. So right here where I just highlighted, that's where I want you guys to, so you're going to click on there to create a personal account, and you're going to sign up with your email address. I guess you could sign in with Google and Apple if you want. That's okay too. I would recommend signing in with email. Okay. And now it's going to ask you a whole bunch of questions. So please answer the questions. It's going to ask for your birthday. The only reason it needs to know your birthday is just so that it knows that you're older than 13. Okay. So you can type in any number you want. So let's say you were born in 1939, although, you know, whatever. Okay. So now I'm clicking next. And so now we type in our password, or we type in our email address, and you type in a password of your own choosing. Notice that, boy, it keeps going away. You need to have one letter and one capital and, you know, all the, you know, the typical restrictions. And then when you click on here, it'll create an account. Okay, so I want everybody to do that. So either log in if you've already got an account, or create an account. And once you've created an account, I want you to come back into the chat box and say, I've created one. I'll wait. Okay, good. All right, looks like a lot of people are done. Okay, now there's one other thing that's important. At least the last time I logged on, Tinkercad won't let you use the account until you validate the account. So what they're doing is Tinkercad is going to send an email to your email address, And there's a link in there that you click on. And once you click on that link, then and only then you can get into Tinkercad. Okay. So your homework tonight is basically just get on Tinkercad and play with it. Okay. You don't have to do the assignment that I posted on Canvas. I'll go in and I'll change that. So I'm going to make it due on Friday. Your only homework tonight is to create an account on Tinkercad. And then once you've got an account on Tinkercad, then I want you to just play with it. I want you to create circuits that have light bulbs in them, create circuits that have LEDs in them, create circuits that have multimeters that either measure the voltage or the amperage. When you go into Tinkercad, the default is for 3D designs. You don't want 3D designs, you want circuits. So click on circuits. And then you go in to create a new circuit. Or you could also, they have a really nice tutorial. Tinkercad is great about tutorials. If you want to just take the tutorial and look through that, I highly encourage it. Okay, so that's your only homework tonight, is basically just play with Tinkercad. Okay, does everybody understand? And are you okay with everything? So give me a yes, meaning everything's good. No, if you're confused. All right, I'm seeing lots of yeses. I'm not seeing any nos. Okay, so you know what to do. Have fun playing with Tinkercad. You will love it. Those of you that already know a little bit about electronics, play with some of those other things. Tinkercad has a wonderful collection of motors and buzzers and Arduinos, and it's also got some integrated circuits. It's got some transistors. Now, most of you probably don't know what a transistor and integrated circuit is. Don't worry, you're going to learn. But the few of you that already do know that, play with it. And you will love Tinkercad, absolutely love it. Okay, before I end class, are there any questions? Not seeing any, not hearing any. I'm going to stop the recording so that you can ask questions that you might think are embarrassing without being recorded.